Hello, I am one student. This is Mrs. Kaufman. I am actually out sick today, but I didn't want us to miss out on a lesson since we only have 3 weeks left. I hope you're remembering your due dates. December 14th is the day to retake, and the last day to retake any tests, and December 15th is the last day to turn in any late homework or classwork. Anyway, so let's go ahead and get out your classwork packet. You can pause the video if you need to. But we're going to be going to page number 10 of your classwork packet and start generalizing arithmetic sequences. All right, so I'm going to change colors here. Let's see if my blue came out good. Okay, so we are learning the language of sequences. So sequences have their own notation and vocabulary to help describe them. I remember we talked about this yesterday, such as term. That was the number in the sequence, and the term number, which was, and I'll use my fun colors here, term number, which is the number above the sequence. So we have our term in blue, our term number in red, the numbers above the sequence, and those are the numbers for that particular term. So let's consider this sequence. We have -9, -5, -1, 3, and 4. And it's asking, is this arithmetic, geometric, or neither? And you're probably going, Mrs. Kaufman, I do not know what that means. So let's write in the little column here some definitions. So the first one is arithmetic. And it simply means that the sequence is adding or subtracting to get to the next term. Then we have geometric. And it simply means that we're going to be multiplying, make the little star, multiplying or dividing to get to the next term. That's a division symbol. All right, so how are we getting from -9 to -5? Hopefully you are understanding that we are just adding 4. That's our pattern. And since we're adding 4, that means it's an arithmetic sequence. If you have a hard time remembering these, the word arithmetic and arithmetic kind of go together. That also helps me with maybe saying arithmetic is adding and subtracting, geometric is multiplying and dividing. So whatever trick you need to remember this, but remember, we can always use our notes on our test. So if you're keeping up with me and doing these notes, you should be okay. All right, so in the next part it says, what is the first term of that sequence? Well, remember I was quizzing you guys yesterday, but our first term is this one right here. So the first term of our sequence is -9. Remember, the number above it is the term number, the number below it is the actual term. So when the sequence generator adds a number to each term, the value that it's added is known as the common difference. And that difference between each term, it's the difference between each term and the term before it. And what is our common difference? 4. Our common difference is 4. Okay, hope you are doing okay so far. But again, arithmetic and geometric are what we're talking about. Are we adding or subtracting to get to the next term, or are we multiplying and dividing? Now it's asking us to graph this. So record the sequence in this table and then graph. So our n values, again, are our term numbers. So I'm just going to write 2, 3, 4, 5, 6, 7, and 8. The t of n is our term itself. So for this one, it's going to be -9 is our first term, -5, -1, 3, 7. What's the next one? 11, 15, and then 19. I'm sure this looks very familiar to you. Now we're going to graph this sequence. So at 1, we go all the way down to -9 and put a dot. So that's, remember, this is our x, this is our y. This is our x, this is our y. Remember, X is always on the left-hand side of the table and Y is on the right-hand side in case you get those mixed up. All right, 2 and -5 is our next term. 3 and -1. 4 and 3. This should be a 3 right here. 4 and 3. 5 and 7. Or 7, oh, a little bit higher. There we go. 6 and 11. 7 and 15. And I think we're about done. All right, so now I have my line. Now it's asking me, should this graph be continuous or discrete? Thinking about back to the rabbits. So when we were doing our rabbits and we had the two parents and the parents would have several babies, and we talked about how, we started initially with 2 rabbits, and then the next month we had how many rabbits? 2, 4, 6. And from here to here, we knew we were multiplying by 3. But one of the key things that we were talking about was discrete or continuous. And each rabbit we count as a whole, meaning that we don't count animals or people in parts. Like I wouldn't say that was 0.5 of a rabbit. I would say it was one whole rabbit. So when I am doing a sequence, I am actually adding that common difference to the next term. So I don't care about the terms in between here. I only want that whole number, or that number that relates to the term. So this is going to be +4. I don't care about the numbers in between. This is also going to be +4. I don't care about the numbers in between. Why? Because it is a sequence of numbers. So that being said, what do you think? Continuous or discrete? I hope you said discrete. And because, why is it? Because we only want the terms in this sequence. Now, we could be multiplying by a digit, like a decimal. We could be multiplying by a fraction, but if we're talking about the sequence itself, we are talking about what is our common difference and how do we get to that next number. We do not care about those numbers in between. So you would not connect the dots. Don't connect those dots. And you keep it discrete. I will check that when I stamp you. Do not connect your dots. It's a discrete graph. Okay. How is the common difference related to the graph? Ooh, this is a good one. You guys ready? Here we go. Notice that I go up 4 and to the right 1. Up 4 to the right 1. It's the slope, right? Our common difference is our slope. It's literally up 4 to the right 1. So how is the common difference related to the graph? It is our slope. We're going to go up 4 and to the right 1. And does that make sense? Absolutely. This is our growth. Remember that slope, another word for slope, we were talking about that earlier, is the growth. And our graph is growing, isn't it? As we go up 4 to the right 1, it's just growing and growing and growing. So there's our growth. Okay. I'm going to rewrite that over there so you can see it a little better. All right, so it says write an equation to model the sequence. Begin with t of n. Remember, t of n is like the y. And this is the same thing. So our graph, if I was to connect these dots, would be a straight line. Notice that it's arithmetic. It's going to be a straight line. So when we begin with t of n, I'm going to rewrite it over here. It's going to be like y is equal to mx plus b. Well, what do I need? I need my slope. Well, goodness, I already have that. It's right here. Here's my slope, 4 over 1. And instead of writing x, I'm going to put an n because I'm keeping that notation the same. And you guys could put 4 over 1, or if you just want to put 4, that is okay. It's the same thing, and I think you guys will agree. And then we want that, the last thing is the y-intercept. Oh, well, how do I find that y-intercept? Let's see here. Let's erase this. And remember, if you didn't write that down, just rewind the video back and you'll see it again. But if I was to just bring this down here like this, and this would be negative 11, negative 12, negative 13. Okay, and I want to go to the left one and down 4. 1, 2, 3. Is that on 9, 10, 11, 12? Yeah. So there would be my next dot. And this, ladies and gentlemen, is my y-intercept. Why? Because it's on the y-axis. It's on the actual y-axis. So I have my y-intercept. What is it? It's negative 12. So I'm going to put that over here, minus 12, on my equation for this sequence. You see how you need all this information? Nothing is ever unused. We use it all in math. We use it all. Okay, so again, this right here is my slope. This right here is my y-intercept. Hopefully that makes sense to you. If you have a question, this might be a good time to pause the video, write that question down, and then I can answer for you tomorrow. It's pretty cool, huh? Hopefully, or not tomorrow. Today is Monday, Tuesday, Wednesday. Hopefully Wednesday. Hopefully I'm better by Wednesday. Okay, what is the domain of the sequence of the equation that you have written? Okay, so the domain, remember, the domain means all these x values right here. Well, look it goes, looks like it goes from here, from 0, there's 0, all the way out to 7, but it could really keep going. It could keep going this way, and it keep going this way, and nothing would restrict it. So our domain, if there's no restrictions, would be from negative infinity to positive infinity. If you just want to do it for the graph that you are seeing, for just the sequence that it shows here, you would go from 0 to 6. Oh, also, I'm sorry. Yeah, for the graph here, it's just 0 to 6. So from here, from 0 to what we have graphed, which is 6. I would take either of those because it shows me that you understand where the domain is. So you could do either one, from 0 to 6 or negative infinity to positive infinity. The last question is an important one. What is t of n if n is equal to 0? So they're asking for t of 0. And that, instead of 4, I would put a 0 minus 12. Well, if I solve this equation for t of 0, 4 times 0 is 0, so that goes away. I just end up with negative 12, which is my y-intercept. So if the n is 0, you know your y-intercept is negative 12. But what else would that be? If it's 0 here, that's our term number. So let's keep going with this idea of this 0 right here is our term number. So we have a couple of definitions. We have the zero term is the t of 0 is the 0th term in the sequence. T of 1 is the first term or the first number listed in the sequence. And T of n is the nth term. Nth meaning any. And if you want to put that little note there so you understand, this means any. It could be 1, it could be 100, it could be 55,272. It's any term in that sequence. And what's cool is you're going to learn not tomorrow, I keep thinking about that, on Wednesday, how to find that any term, which will be interesting. Okay, so consider this sequence. So we have T of n is equal to -4, -1, 2, and 5. And what you might want to do is just list the terms above it so you know this is term 1, term 2, term 3, and term 4. So we have -4 to -1. Looks like I'm adding 3. So my common difference I already know correctly is going to be +3. I already know what the first term is. It's right there. It's -4. Why? Because I just listed it. But how would I find the t of 0? Well, if I rewrote this over here, this is going to be 1, 2, 3, 4. The sequence is 4, -1, 2, and 5. And I just put it in a quick table. If I wanted to find 0, what would I do? I know I'm adding 3 when I go this way. What would I have to do to go that way? If this is +3, to go to the left to find that t sub 0, I would subtract 3. And if I take -4 and subtract 3, I get -7. -7 is my 0th term. And remember, we knew that our 0th term was our y-intercept. We had our common difference, which we knew was our slope. So now we can write the equation for t of n and verify the equation works with the first term in a sentence, in the sequence. So let's do that. So t of n should be our common difference, 3. Remember, instead of x, I'm just going to put n, minus 7, which is our y-intercept. But let's just verify with the first term and make sure it works. So t of 1 is equal to 3 times 1 minus 7. So t of 1 is equal to 4. 3 times 1 is 3, huh, kids? Minus 7. So t of 1, 3 minus 7 is -4. And notice that it lines up. Here, first term is -4. The first term is -4. So it works. I could put any term number in now and find the value of that term in the sequence. So let's try that. Let's see. Is it possible for t of n to equal 42? So we want to know, this is what this question is asking. If t of n is equal to 42, so what we want to do is say 42, this is our equation, is equal to 3 times n minus 7. Oh, we should make some more room over here so we can solve for n. Let's do that over here. T of n, 42 is equal to 3n minus 7. All right, we are solving for n. We've been practicing this a lot, but I'm hoping that you know that our first thing we're going to do is add 7 to both sides. 7 and 42 is 49. And then we have 3n. And then what is our last step? I hope you know that we're going to divide both sides by 3 because I want n by itself. That makes this go away. This has gone away. And this is 49/3. So the question was, is it possible for t of n to equal 42? And my answer is going to be no. You'd be like, well, why? Because the term number that I should have found should have been a whole number. Remember, our term numbers are 0, 1, 2, 3, 4, 5, 6, 7. We do not use fractions for term numbers. So this does not work. So you would write not possible. Term numbers are always whole numbers. Not possible. Term numbers are always whole numbers. These are our term numbers right here. And they will never be a decimal or a fraction. All right, take a moment. If you have a question, I would write it down now. And we're almost done for those of you that are getting antsy. I'm just going to erase this so you can see the next question. So for the function, f of x is equal to 3x minus 7. And notice that looks very similar to this one up here. Is it possible for f of x to equal 42? All right, well, let's try it. So we're saying instead of f of x, we're going to put 42 is equal to 3x minus 7. We're going to do the same steps that we did up here. We're going to add 7 to both sides. 49 is equal to 3x. We're going to divide both sides by 3. That goes away. X is equal to 49 over 3. Now, it's the same answer. But with a function, does it matter that we have a fraction or not? And the answer is no, it doesn't matter. So, is it possible? Yes, it is possible. Because we have no restrictions of that sequence or that common difference. We want every point on that line. So let's sum that up in this bottom sentence. Explain the difference between t of n and f of x that makes your answers in part B and D different. So t of n grows by common difference. Only want numbers in sequence. But f of x grows by the slope, and we want all numbers on the line. All right, take a moment again, write down a question if you have it for me. If you do have a good question to ask me that's related to this, I will give you a homework pass. You know, it pays to really get to the end of this video. All right, I hope you guys have a great day. I hope to see you on Wednesday, and we'll talk then. Email me if you have any questions.